So, a very good afternoon to everybody. We will continue our discussion on user defined function. User defined functions are the functions that we write as a programmer, and they are very much similar to built-in functions like printf or scanf, but sometimes in our program the functionality that we want may not be provided by any header file. In that case, we can write our own function. And the advantage of function, making it as a function, is that reusability. We can call, say, a function any number of times with the different arguments, and based on the arguments we pass to that function, we get the result. So if we did not have add function, we would have to write whatever we are writing in add here. Again, next time when I want to call use add function, I will have to write all these statements again. Or consider you have a function for finding the factorial of a number. If you are not using a function, user defined function, so when we first time in your program, when we want to find the factorial, you will have to write maybe 5-6 lines of code here, first place. Later in your code, you want to find the factorial of another number, you will have to again write the logic or 4-5 lines of code. But if you are making it as a user defined function, then it is pretty easy. You just need to call that function any number of times with the different values. I will demonstrate that example probably. So here add is like that only. I want to add two numbers, so every time I pass different numbers, I get the result here and I print it. Okay, so continuing with, so we had a function which doesn't take any argument and doesn't return anything, just print a message. So what we did the function call. Without your calling that function from main, that function will not be executed, because main is the function that will be always executed when you are executing your program. So if you want to execute any user defined function, you have to call that function within main. So yesterday we saw the sequence. When I am calling this function, actually execution goes to this function and all the statements will be executed. Then it will come back to main program, and then it will call the next function, add function. When you are calling it, it will go here, execute all the statements with the values of x and y. X4 will go to x, 5 will go to y, and the sum will be computed and it will be returned back. The returned value will be stored in this variable s. Then I can print the sum. S will be having the sum and that can be printed. Later I want to add two other numbers. I call add function again and pass those two numbers. Again the execution will go here, and now x will get the new value 10 and y will get the value 15. X plus y will be computed 25. The result is returned back and we are writing into the same variable s. So 9 assigned to s previously will be overwritten by the new value 25 and we are going to print it. So this is what is happening in case of user defined function. So reusability is one advantage of using user defined function. If you have a user defined function, you can call it any number of times from your main with the different values. We get the corresponding result. Now we can pass variables also. Here I am passing constants. In that place you can pass variables also. If I want to pass, say, int say a equal to 100, b equal to 200, I can call the function with the variables also, no problem. So I'll pass a followed by b. So what happens? Value in a will be copied into x, the first argument to this function. Then value in b will be copied into y. Then again it will be x plus y, where 100 plus 200 is done. and the result is stored back into S. Because I am returning sum, that is why the result is getting stored into S. If I don't return, this operation will not be possible. Okay. Yeah. So what will be printed here? If I am running this program for this function call, so I called add first time here, then second time here, third time I am calling with two variables. First and second time I am passing two constants. Now I am passing two variables. So what will be the result printed? Can anyone tell? What is going to happen here? What will be the result printed here? This statement, the sum is nobody is able to tell. Okay, I'll pick up. Harikesh. Harikesh, what will be the result? Then anybody? What is that I am doing here? I am passing A and B, which are having values 100 and 200 into the function I wrote yesterday. What it is doing? Those values will be taken into or assigned to X and Y respectively, and we are finding the sum. Then that sum is returned back, that is assigned to variable S. So effectively what is it finding? The sum of A and B. So I get 300. So first one, 4 plus 5, this is 10 plus 15, this is 100 plus 200. Harikesh, are you there?
Yes, sir.
Why you didn't respond when I asked? Is it difficult? Did you understand this?
Yes, sir, I understood.
Then why did you not respond? This is such a simple. Yesterday we already did. I step by step I executed this, and I showed that how 4 and 5 are getting stored in X and Y when I am making this function call. So I am making three function calls here. First time calling my user defined function with two parameters 4 and 5. So you can literally see that. I'll put a breakpoint here also. So when I am executing this, I am here. Execution will start at main all the time, irrespective of whatever user defined function you write here. Execution will always happen in start with the main only. Now if I see the output window, hello world is already printed. Why? Because this is executed, and in that function we have one statement, printf hello world. So hello world is printed. Now we are about to execute this function. Okay, so if I do that, see, because of this function call, our execution goes here, and it has printed what happened. Yeah. Shift. Okay, we'll take it one more time. So we are here. From there we need to go inside. So Shift F7. So now we are here. Then next line. So if I go here, I can see I am in add. Because of the first function call, this is a function call. I am calling that function. I wrote the function here. I am calling that function. And because of this function call, I am here now. Execution is here. Now you can see that x is getting the value 4 and y is having the value 5. 4 and 5. Now x plus 5 means it is 4 plus 5. And execute the next statement. There we are, sum is having 9 now. When we are returning it, s gets that value. So whatever function returned will be stored in y add function will be stored in s. Now s gets 9. And now here we are going to execute printf, which is a built-in function we are calling. Here user defined function we are calling, here we are calling the built-in function. And we are printing the value of s. So if you see the output, 9 is printed. Now I am calling the same function with the two different values. Again execution goes or jumps. It is jump execution is jumped from here, this location to this location. And second time I am in add is coming. Then adding the two numbers. Now you see x, because I am passing 10 here and 15 here, x is getting, when I am executing this function, x is getting 10, y is getting 15. X gets 10, y gets 15. So x plus y is 25, that will be stored in sum. So sum variable gets 25 and I am returning it back to the place where I called this function. I called this function in line number 26. So it comes back in line number 26. Now if you see value of s, it is 25. Now we are printing it. Again we are passing two variables having some value stored in this. So I'm calling this, it goes in here. If you see, x gets the value, x is here, x is in the user defined function. There we call it as a and b. Here x is there in the user defined function. So x gets the value 100, y gets the value 200. Sum is 100 plus 200, sum will be 300. So sum got the value 300. We are returning it back to the place where it is called. Now s is assigned with 300. If you see, it is 300. We are printing it. Okay. So we are done with the three function calls for the function we wrote, that is add, which takes two integer variables and simply add them and return the result of it. Did everyone understand this? Anyone has a doubt about these things, you can ask now. This is very important. If you want to learn any other programming language, you will have to understand this, because in every programming language there will be functions. If any question is there, you can ask now. Okay. So let's make this a program, assignment program. So this will be your sixth program. Fifty, 16, 21, 22nd program. 5 programs from strings, 22nd program for your assignment. UDF user defined function 1 dot C. So you can take a snap of this. Okay, you can take a snap of this program. This will be the 22nd program of your assignment part 2, or overall 22nd program, assignment part 2, 6th program. 16 programs you have already written in part 1, so this will be the 6th program in part 2. 5 programs are the string operations without using built-in functions. Okay, so then we will move on. Yeah, so I'll make this program shorter, shorter in the sense I'll remove these programs. Hope you understood this. I'll write another program, basically finding factorial. You already know how to find factorial of a number given that, so I'm going to write a user defined function for that. So my return value will be an integer, because factorial of an integer is an integer only. Okay, and I'm going to name that function as factorial. There is no built-in function called factorial in C. And what is the input or input argument? It will be another integer, so I call it as, say, n. So the input to this function is one integer and the output also an integer. If input is 5, 5 factorial should be returned by this function. That is the intention. So I write this function. So locally I am declaring a variable I is equal to maybe 1, then factorial equal to 1. So basically 0 factorial is 1. So in that assumption we are making factorial is equal to 1. Then what I'll do is I'll use a loop while I less than or equal to n. As long as I is less than or equal to n, we want to execute this statement factorial fact equal to fact into I. I. So initially I is equal to 1, fact equal to 1, it will become 1 into 1. So next time, before executing the next iteration, I am incrementing I to 2, doing my I plus plus. Next time it will be 2 less than or equal to n, fact equal to fact into 2. Okay, so cumulatively it is going to add, it will effectively become 1 into 2 into 3 into etc. up to n. 1 into 2 into 3 into etc. into n. This loop will result in. So we have already done this in our looping examples. The only difference is that I am making a user defined function now. So I am making it as an independent module. Okay. Now after this, if after this condition is false, we will come out of this loop. At that time, fact will have the factorial of n. Variable fact will have the factorial of n. Okay. So what I should do? I should return that to the function that called my user defined function. So far we have not called from anywhere. So if I execute this program, I am not going to get any output. We are not calling it. We don't have any printf message in our program. That's why we don't get any output. Now if I want to find factorial of some number, what I need to do? I need to call the function with some input value. Suppose I want to find factorial of 5. So I have to call the function factorial, which I have written now, with 5. Okay. Now even after doing this, I will not get any output because I am not displaying the result. So what I should do is, maybe I will declare the variable f. I will put f equal to factorial of 5 in the format y is equal to f of x. This is now in the format y is equal to f of x. Instead of y I have used f. Instead of function f I have used factorial. instead of the argument x I have passed 5. So now what will happen, whatever value returned from this function will be stored in f, that I can print factorial of percentage d is percentage d. Now first percentage d I want say okay, it is 5, or I can make it generalize it, n equal, I'll make it n equal to 5 and I'll pass n is equal to 5 and I'll pass n. So factorial of value stored in n is the value stored in f. So this, in this place value of n will come, in this place value of f will come, f is the value, factorial value. Okay, now if I execute this I might get a valid output. So factorial of 5 is 120. Okay, now if I want to find the factorial of some other number, I want to find the factorial of 6, I'll change it to 6. Okay, so same concept that I explained. Now we'll ask the user printf enter the number. User will enter the number. We need to scan that into the variable n. Ampersand n. Okay. Now this initialization is not required. Anyway, user is going to enter the value. Okay, whatever value entered by the user, for that we are going to find the factorial. So user enters 2. Again next time user enters 4. 4 factorial is 24. 7. Like that we keep on getting whichever number user enters. So the advantage is that now I have my factorial function, just like we have printf or scanf. We can call this function any number of times with an integer input and we'll get the factorial back and we can print that. Okay, so is this program clear? We have not done anything extra like logic part. We already know how to find the factorial of a number. So here it is n. Here also I am using n, but this n belongs to this function, main function, and this n belongs to factorial function. Both are different. Only thing is that the value in this variable n will be copied into this variable n. So here I can use a different name also. If you use same name for n here in main function as well as in factorial, no problem. Anyway, they are different. This n is different from this n. This n belongs to this function. We call it as the local variable of factorial function. This n is a local variable of factorial function, and this n is a local variable of main function, and they are totally different. This one has 4 bytes of memory allocated to it, and this one also has another 4 bytes of memory allocated to it. So that means they are totally different variables. They happen to have same names. It's like there are 2 students with the same name in your class, or there is a student with certain name in your class and there is another student in another class with the same name, like that. Okay, now I can use a different variable name also, no issue, but they are totally different. Okay, I can use x here, then I will be changing it to x, I will be changing to x here. Still my program is going to work for any input. Okay, so so this is factorial user defined function we have written, and we are making use of that function to get the get the job done for any integer passed to that. Okay, now there are certain terminologies related to user defined function. One is the function, the implementation of that function itself. Okay, we call it as function definition. Function definition, that is the implementation of the function, that will have the title or the signature of the function, which specifies what is the return value of the function, then name of the function, how many arguments are there, and what are the types of each argument. So in this function we have only one argument. Previously we had a function which had two arguments, and both of them were integers, and it is not necessary that all the arguments are of same type. You can have a character, pass a character, you can pass float, double, any built-in type, or any user defined type like a structure. Okay, here any combination is possible based on what function you are writing. If you want to add two floating point numbers, you will change it to float type arguments. Like this you will change. Or if you want to pass a floating point number and an integer, this way you can pass. Okay, any combination is possible based on the requirement of your function, the function you are writing. Okay, we will come back to the program we are dealing now. So this whole thing is called function definition. Okay, the implementation of the function. There will be a header of the function. Header, this is the header or the title part where we specify what is the return type, name, number of arguments, and the types of arguments. Here number of arguments is 1 and type of argument is integer. Okay, some other place you will have multiple arguments like this you may have. So type number of arguments are 2, types are one is integer, another is float. This way you will, in this for factorial you don't need 2, you need only one integer. Okay, so this whole thing is called function definition. Now wherever you are calling that function, this is called function call. This is another component of user defined function. One is function definition, another is called function call. So this is function call. Function call typically it will not specify return type or type of argument. Function call will normally have name of the function and the actual data variable or the constant you are passing into it. And if there is a return value for the function, normally you may store it in a variable. So a function call looks like this. Just name of the variable, name of the function, and the argument you are passing into it. This argument can be a constant or a variable. Normally should be matching the type here. If you are in definition, if you have an integer variable or integer data, you should pass an integer constant or an integer variable. Normally that should be the way you need to do. And if you want to store the return value, you make it in the form y is equal to f of x. Here f equal to factorial of x. Y in the format y is equal to. What if you are omitting it? This is also perfectly fine. The only thing is that the returned value factorial of x will not be stored in any variable in this main function. So if you are trying to print it, this will not print the correct answer. If I run this, I am getting 0 because f got a random default value 0. If when I am declaring it, it got a random value, garbage value 0, that is getting printed. So if I want to get the result back in my main function, I need to call it. So whatever we return here, if I want to get it access that value in my main function, I have to assign it to a variable, and then value result will be stored in this variable. We can display it. Okay. Now first terminology, function definition. The entire function, the user defined function, including the header part or the title part and the body of the function. This is the function call. We are making use of that function which we wrote. And there is one third terminology called function prototype. Function prototype, or also called as function declaration. Okay. Now what is that? Actually, I am writing the function implementation before my main function here. Now if I have 10 functions, if I write all the functions before main function will be at the bottom. Okay. But you know that every time when you are executing a program, main function is going to execute. Main function is the first function that is getting executed, and other functions will be executed only if we are calling other functions from main. Now somehow you want main function to be in the beginning, not after all the functions you are writing. Here also I am writing two functions and then main function. So instead of that, if you want main function to be coming in the beginning and all this function implementation at the end, it is possible. Okay. So what I will do is I will take this one, I will cut this from here, function definition of my factorial function, and I place it here. Okay. Now I will try to compile this and I will see the logs. One warning: implicit declaration of function factorial. Implicit declaration. I am getting one warning. Sometimes it will be treated as an error. Let me see whether my program is working or not. Yeah, it is working, but sometimes it may not work also. Okay, so let me see if this program is working. I'll put this one. I'm putting these two functions below, but I have to copy it there. I'll comment the entire thing. I'll put the previous program. The previous program of adding here. Main function is in the beginning and the user defined functions are at the end after the main function. Let's compile this. I'm getting 3 warnings actually. So when I'm writing user defined function after the main function, I'm getting warnings. Sometimes warnings will be strictly dealt just like your ebox program. Now if I'll try to execute this. Yeah, it yeah, it seems to work. Some seems to work. The compiler is smarter. Now how to avoid this warning? I'm getting 3 warnings. The function I'm getting 3 warnings: implicit declaration of function say hello, implicit declaration of function add, again conflicting type for say hello. 3 warnings I am getting. Okay. Now how to avoid this? Our purpose is we want the main function to be in the beginning and user defined functions all later. Okay. Now if I put that way, I am getting so many warnings, and sometimes these warnings may result in an execution error also, wrong result also. Okay. So how to avoid this thing? that can be avoided using a function declaration. So what we need to do is, if you are defining the function definition is after the main function, you need to declare that function before the main function. So what I am doing is, I am just declaring means I am just providing the title of the function, just providing the title of the function, not the body of the function. Okay, so say hello, I am providing the title of the function. This is, we are just telling the compiler which will process this program, we are telling the compiler that such a function is there somewhere down the line. That is the declaration. So function declaration. Okay, so I declared one function, then I compiled. Now I have only one warning: implicit declaration of function add. The meaning is that since the declaration of function add is not found, the compiler is trying to declare itself, trying to do the declaration by itself. So to avoid that warning, what I am doing is, I'll just take the title of this function, or we call it as also as the signature of the function. Again I'm going to put it here. Now if I compile, I don't have any warning. Okay, zero warnings. So this is what is called function declaration. That is, just provide the title of the user defined function you are going to write or implement later before the main function, and then write your main function followed by all the function definitions. Function definitions. So three terminologies: function declaration, just where you are going to provide just the signature of the function or the title of the function followed by a semicolon. Then you have function calls, and later after the main function you have the function definitions. Okay, so I will take this one back to our assignment. Okay, now we will take our factorial program. Okay, so what we did is, the factorial function which we defined before the main function, we moved it to below. The function definition is now here after the main function, and this was also creating a warning during the compilation: implicit declaration of factorial function. I am getting a warning. To avoid that, what I will do is, I will take the signature of the function or title of the function and put it here and semicolon. Now if I compile, I get a clean compilation, no warning, no error. So this is the function prototype or function declaration. Then you have the function call, where you are calling the function. This is the normal typical syntax of it, or typical way you are doing it. And here you have the function definition. Okay, this is one way of doing it. It looks better organized, so that your main function is in the beginning, because main function is the first function that will be executed in the program. Here you have the declarations of all the functions. Here only one function is there, so I have declared it, and later after the main function I have the implementation or the definition of the function I have written. Okay, now I have used, in declaration I have used n. It is not necessary actually. I can use a different variable name. In the definition I have used n. I can use a different variable name or same variable name, but the return type and name should be matching, and the parameter type should be matching. The variable name of the arguments, the name of the arguments you are passing into the function can be different in the declaration as well as definition. Okay, so after doing all these things, still our function is working, our program is working, we will check. Yep. Okay, is there any question about what we have discussed today? Not much. Three terminologies: function declaration or prototype, function call, function definition. Then we have seen one more example, factorial, user defined function factorial, and how we are making use of it in our program. Any question is there?